Hi, this is a screen recording as the orientation of this class. So instead of talking about this in the class, which makes it a little bit hard to record because of the classroom setting, I'm going to do this on my desktop before the class. In order to access the class material, you have to log into Moodle. The URL of Moodle is www.someprofs.org, and you should have received a message regarding the login detail because you are a student of this class. If you forget your password, there is a help to reset your password. Let me just display where you can get some help. When you first get to the Moodle website, even without logging in, you already have access to this part of the resources. And one of these is a video clip to help you reset your password. And I suggest you to read that part or watch that part just in case you lose your password and have to reset it. It's actually a pretty simple process. So let's go and get into the class right now. This is the homepage of cisn120, beginning network administration with Linux. And this is how I organize the class at this point. The first thing we want to start with is the syllabus. There are two versions of the syllabus. One is in HTML and the other one is in PDF. They have exactly the same content, so you can print out either one or read either one, and they have exactly the same content. And for the purpose of using because I'm using a web browser, it makes sense to use the HTML version. If you want to print one and put it into your binder, then you might want to use the other version. I mean the PDF version. And it's not opening this inside the same window, so let me just force it to open here. There we go. This is the syllabus of cisn120. The section number or the course number is 28466. The first part of this has to do with information about the course, which is basically just a copy and paste from the catalog, so you should know this part already. This course covers the basics of installation and administration of the Linux network or operating system. Topics include installation of the Linux server, connecting to a network, utilizing network utilities, administering and maintaining network printing, protecting network data, and installing network applications. This course also covers planning, assessing, and managing file systems, planning and implementing login and file system security, administering and maintaining user accounts, upgrading the kernel, and backing up servers. So that's a lot of topics to cover in a 5-week class. Student learning outcomes include: describe the major components of a Linux network operating system, discuss Linux licensing and copyright issues in layman's terms, design, build, and maintain a logical and organized electronic file system, analyze and construct user accounts and groups using best practices for security, utilize the basic Linux network utility to troubleshoot network connectivity, install and configure network printing resources, install and configure network server applications, analyze system backup methodology and best practices for scheduling backups and restoring files and system state data, plan and implement a recompile of the Linux kernel, and research and identify good internet resources for obtaining answers to common problems, network anomalies, and Linux server problems. So let's move ahead a little bit here. Our meeting place, I forgot about Wednesday, so this should be updated later. It's Monday and Wednesday from 7 to 9:15 in room 152, section D. We have 45 lecture hours and 27 lab hours in this class. The final exam is our last meeting of the class, which is scheduled on September 26, 2011, and this is just a regular time when we meet in the classroom. Okay, a little bit of information about myself. My first name is Tak and last name is Onyang. This is a hyperlink to the Wikipedia of my last name. So in case you want to know, where the last name comes from and stuff like that, that's a resource. My office is in room 7 of Liberal Arts 133. The phone number is 484-8250, and you can use either email address. It's either the ARC web address or the Dr. Tak address. And my office hours are Monday, Wednesday from 5 to 6. Tuesday and Thursdays, it will be from 9:30 to 10:30. And on Friday, it's going to be online from 1 to 2 o'clock. That may need to be changed later on in the semester. Now we're going to go over behavior expectations. Universal, which means it doesn't matter where you are. The first thing is no disruptive behavior is tolerated, because we are here to learn and I'm here to teach. So I don't want any disruptive behavior to prevent other students from getting information or just taking a class. If someone wants to chat, that person can chat outside of the classroom. If someone wants to talk on the phone, that person can talk on the phone outside. And if you feel that someone has been disruptive and I have not addressed that issue, please let me know. Okay. The second part, this part is new. No disrespectful behavior is tolerated. That basically includes people who are going to text, who want to text in the class. They can do that outside. People who want to play games in the class can play games outside. These are just examples of what I do not tolerate in the class. The third one is a big item. Basically, that has to do with cheating, academic dishonesty. And there's a link here to further describe what is considered academic dishonesty. And the most important part is what happens when it does occur. It will be documented. It will be sent to the discipline officer. The discipline officer of the campus will determine the appropriate action, and that can be a lot of different things. For sure, whatever work involved, it can be an assignment, a quiz, an exam, or whatever, that will receive a maximum score of 0. And it can also trigger reinvestigation of prior work, which basically means the grade of whoever is cheating can actually get lowered, because I will go back and double check on all the work that has been submitted. When we meet face to face in the lab and also in the classroom, there should be no phone calls, no phone ringing, no drink, no food, and no kid. And if you have a question, raise your hand and ask and wait for me to acknowledge that. In terms of attendance, now this is a big thing, especially when in a 5-week only class. 6% or more unexcused absences is considered excessive. Okay, so it doesn't take much to make up 6% when we have a 5-week class. So you got to make sure that you can come to every single class. There are only a few excuses that I have to accept. The first one is a military duty excuse. The second one is a jury duty excuse. And the last one is a medical reason as an excuse. Other excuses may or may not be accepted. The health center can help you verify medical excuses, and it is free. Okay. And now we are moving on to online resources. All students are expected to check email at least once per day, and that's only counting weekdays. Email should be sent with the following information. The subject line needs to indicate the course name. In this case, it's cisn120. You don't need to tell me what days we are meeting, because there's only one section. And also you have to describe the nature of the email. Tell me about the content of the email message. Just a title, a subject line. The body should include the detail of the question or comment, and I also need to know who wrote that email. So this is a guideline for people sending email to me. And now we're moving on to resources. Resources basically it's just email. This is the official point of contact. When Moodle sends email out, it's going to send it to your email account. So you got to make sure that your email account either you check your email account or you set it up to forward to whatever account that you'll be reading. The Moodle resource at someprofs.org is the course management tool that I use, so I do not use D2L in this class. Grading, no makeup submitted work unless it is excused. Definitely no makeup work once the solution is disclosed, even if it is excused after the fact, because there's no way that someone can still turn in any work when I have told everybody about the solution. The letter grade equivalence is pretty easy. Less than 1/8 is an F, and then we have the next 25% getting D's, the next 25% getting B's, the next 25% getting B's, and anyone with at least 7/8 of all the available points will get an A. And in this class, we'll have the homework, first exam project, and also the second exam and project taking up about 60% of everything, each one taking 20%. The final exam or the final project by itself will take up 40%. And here is our proposed schedule. It is very, very full and very busy. On the 22nd, we'll talk about client-server networks and Linux administration, and how Linux relate to Unix and Microsoft Windows. We'll actually talk about it in this video clip too. The second part, we'll talk about Linux licensing and copyright issues, public domain, GNU public license, the Free Software Foundation, and we'll talk about that too. And we'll also do a quick review of the command line booting and shutting down the Linux server, and I'll throw in something else because I'll also throw in my live Linux distribution, as well as how to use a virtual machine. Alright, so let's go ahead and get started here. I'm switching back to the class site, and what I'll do is I'm going to switch. Oh, there's one more thing I almost forgot. I am not going to give you a printed version of the syllabus. So the way you have to do, so what you have to do to let me know that you have in fact received the syllabus is log into the website. So let me change my role to a student so we'll see exactly what you should be seeing. And what you need to do is to click syllabus acknowledgement. When you click that, it simply asks you a question. Either you can click I found, read, and understood the syllabus, or you can click what syllabus. Anyone who clicks what syllabus will be dropped from the class. So I need to get this done before the second meeting of the class on Wednesday, the 24th. So that's your first homework assignment, is to deal with the choice activity. And so what we want to do now is to go back to the syllabus and start to talk about these things. So we want to talk about how Linux relates to Unix and Microsoft Windows. One of the best resources online is Wikipedia. And you can go to Wikipedia and search for Linux. And of course, Linux is going to have a very, very long entry because it has been around for a long time, and many people want to contribute to an article about Linux. Well, the first thing we want to know about Linux is it is related to Unix. You can tell the name ends with an X, but it's not Unix. So Linux does not conform to all the standards that apply to Unix, but it is close enough that many programs, many application programs, and server programs that are designed to work with Unix would also work in Linux. There are several things that are noteworthy about Linux. The first one has to do with, the first one is it is licensed under the GNU public license. So here is a link to the GNU General Public License, or GPL. So let's go ahead and open the new tab here. The GNU General Public License also has a really, really long description. Linux is licensed under version 2 of the GPL, and in this case, the major change in GPL v2 was the liberty or death clause, as he calls it in section 7. If somebody has restriction imposed that prevent him or her from distributing GPL covered software in a way that respects other users' freedom, he or she cannot distribute it at all. So in other words, GPL v2 makes sure that open source software remains open source. There's no way you can convert it back to non-open source. And there's also a lesser version of the library general public license. The L part, is there are multiple interpretation of the LGPL, the first L. But we won't talk about it because Linux is not licensed under the LGPL. It is actually just licensed under the GPL. And what that means, okay, when we say that Linux is licensed under the GPL version 2, the essence of that is, one, the source code is available to anyone who's interested. And the second one, which kind of follows the first one, is anyone can get Linux for free. Now, it does not prevent people from selling images of Linux already installed on a CD, on a hard drive, on a computer, and etc., etc. But those people have to make it clear that other people can also get Linux for free and where to get it. So that's why Red Hat can distribute Linux and charge money for that, because what they have to do is to tell people that yes, you can buy it from us and have us provide the service, but you can also get Linux from all these other places and you can get it for free. The person who wrote Linux is Linus Torvald, and there should be a link here to Linus. So let me search for that name. And here's an entry of Linus Torvalds. He is the inventor or the original writer of Linux. And this is also a rather long documentation. But basically, he wrote Linux because at the time there was no available free Unix operating systems. The only alternative was Minix, but Minix was not free because the publisher actually has the rights to Minix, which is also a clone of Unix. So Linus decided to rewrite everything from scratch, and he succeeded in doing that. And also because it is open source, he also can use the help from many other developers to make Linux better, more feature rich, and so on and so forth. Okay. So what exactly is Linux? Linux is an operating system, but what is an operating system? And we can also look this up in Wikipedia. So let's look up operating system, and here's a very good picture of an operating system is. Now this is obviously a very long page, and it contains a lot of information that we don't really need to talk about at this point, but this picture all by itself is very important. So let's click it and get a better view of this. This picture shows all the layers of the various, I would say, players when a computer is used. At the bottom layer, this is really easy to understand. The hardware is easy to understand. Basically, the box of a desktop computer and all the components inside can be considered the hardware of a computer. If you have a laptop computer, then the entire laptop computer is the hardware of the computer. If you have a tablet, the whole tablet is considered the hardware of the computer. So that's pretty easy, and I think most people don't have any problems with an understanding of hardware. Let's skip the middle two layers and go all the way to the top. User. Well, when we talk about user, we typically think of, oh, it's a person who's using the computer to do something. It can be gaming, it can be word processing, can be crunching data in the database, and so on. But in this class, because we are talking about Linux as a network operating system, the user can also be another computer that is remotely connected to a computer through networking. So when we think about user, it's not just limited to a person, who is going to use the computer, that's who is sitting next to the computer itself. It can also be another computer. It can be another user of another computer using the network to access this computer. It can also be an automated program on another computer trying to access this computer, or the computer that we are talking about, through the network. So the definition of user is a little bit more general than the usual meaning. So that's taken care of. Now we are left with the middle two layers. The first one is application, and the next one is operating system. So let's talk about application first. Users typically interact with applications. A very typical application is a word processing software, a word processing program. That's an application. A spreadsheet program is an application. A photo editing software is an application. That's how we understand application in a normal desktop computer. When we are talking about a networked server, what exactly is an application? Well, in those cases, applications are a little bit different. Okay, the definition of an application is a little bit different, because in those cases, an application does not really need a GUI, does not need a user interface. What it does need is to provide a service. It needs to provide a service or services to the so-called user. Let's think about a print server. Okay, a print server can be considered an application. What it does is it provides multiple services. What exactly are those services? Well, the services are fairly simple. To let a user go through the print server program in order to access the printer, which is hooked up to the hardware. Can be through USB, can be through a parallel port, and etc., etc. Okay, so if a print server is an application, that means the whole term, how we understand what an application is a little bit twisted now. Okay, and we'll talk about client-server relationship later on. But basically, a user becomes a client, and the application becomes quote-unquote the server. The client requests a service from the server, and the server will go through the other layers to actually provide the service, and that's how it works. So we have now talked about the user, someone who needs some service from a particular computer, possibly remotely connected through the network. We talked about the application, which are basically servers in order to answer the request of a client. We talked about the hardware, which is basically all the physical components of a computer and all the peripherals that are also connected to that computer. So what is left now is the operating system. What exactly is the operating system? The operating system is, well, there are several ways to look at an operating system, but the first one and the most important one is an abstraction of the hardware. In other words, you can connect different hard drives to your computer, and the operating system, together with its many components, will present a uniform interface to an application. In other words, the application does not need to know that you're using a Western Digital hard drive, that you're using a Seagate hard drive, that you're using an internal serial ATA hard drive, that you're using an external USB hard drive, that you're using a network drive, and so on and so forth. As far as the application is concerned, because of the abstraction provided by the operating system, it is simply a drive. It also provides more abstractions. The operating system also includes a file system concept. In other words, an application does not need to know exactly which sector to put what kind of data in order to represent a file. The file system inside an operating system takes care of that, and then it will interact with the hardware to store or retrieve or delete and do other types of modifications to a file. So that's why an operating system is so important, because it provides an abstraction so that people who are writing the application do not need to know the exact details of the hardware that is available, and only needs to know the abstracted interface of the hardware that needs to be used. So that's a quick introduction to what an operating system is, and Linux is an operating system. It is not an application. It's also not an hardware. It's not hardware. So one question is, how useful is Linux as an operating system? And I can tell you right away, it's not useful. What? So what are we talking about in this class? I mean, why do we have so many classes and so many people are interested in Linux? Well, that's because Linux, as an operating system, supports a lot of different types of applications. And it's the combination of the application and the operating system that makes the two useful together. You can have an operating system. It can be very solid, efficient, secure, and reliable. But if there are no applications developed for that operating system, then the operating system is completely useless. So that brings us back to Linux, because now the question is, well, if Linux is a good operating system, but it's useless without applications, so where do we find the applications? So here we're going to open a new link here, and what I'll do is I'll go to the Debian website. Debian is one of the many distributions of Linux, and let me go to this part here. This page explains what Debian is, but basically what Debian is, or the Debian distribution of Linux is it's a system that consists of the operating system itself, as well as a huge selection of applications and other types of software and components that you can use with Linux. So now we are not only talking about the operating system, but we are also talking about all the other components in order to make an operating system useful. Now Debian is also a distribution system, and the way it distributes the system is by using the network. You can also use DVDs and CDs to do that, but the most common way to distribute components of Debian is through the network, and I'll illustrate how to do that later. Let's go back to the syllabus to make sure that I'm not going too far off track here. We talked about the relationship of Linux to Windows, and also to well, I guess we haven't really talked about that. We talked about how Linux relates to Unix. It's basically a clone of Unix, but it does not comply. It's not entirely compliant to the standards applied to Unix. Linux does not relate to Microsoft Windows in terms of its design, coding, and philosophy. The only thing I can think of that relates Linux to Microsoft Windows is they can talk. Linux has many components that are designed specifically to talk to Windows. I'm not quite sure the reverse is true, but the two can cooperate. We can set up a Linux file server that a machine running Microsoft Windows can access. We talked about the licensing and copyright issues because Linux it's not public domain. Public domain is not the same as open source. We did talk about the GNU GPL. which basically sets a software component or a program, has the source code available to everybody, and it is available for free. The Free Software Foundation is the origin of the GPL or the GNU GPL, and the open source movement is basically, more and more developers are making their software available, at least the source code of their software available to everybody, because then it can be improved by other people. So now we're moving on to this part here, review of the command line, booting and shutting down of the Linux server, and we also, we'll try to talk about some of the core system services. And in order to do that, it is a good time to talk about how do we start up a Linux machine. Where is the Linux machine? I mean, if we have to talk about how to start up and shut down a Linux server, don't we need access to a Linux server? Well, that's a good question. The first thing we have to talk about now is the term server. Is there a real distinction between a Linux workstation versus a Linux server? And the answer is no. There's no distinction whatsoever. Because unlike Windows, which artificially draw a line between the workstation and a server, Linux makes no such distinction. A Linux server can easily be a workstation, and a workstation can easily be a server. They can cross over. They can be both. A machine can be both at the same time. So that's the first thing we want to do, is to take away the term server when we talk about Linux server. Basically, we just need to talk about how to start up and how to shut down a Linux machine. Now that's a very good topic, because now we have to talk about, well, but we don't have a Linux box. So how do we practice doing this sort of thing? Well, I have the solution for you. Let me start up a virtual machine and drag it into the portion that is already being recorded. And here we have it. Now this is a virtual machine, which means it is actually a PC running inside a PC. The startup screen is because of the a live distribution, and the live distribution of Linux simply means that you can put in a flash card, a USB drive, external hard drive, or CD-ROM with this image, and what it would do is it's going to start up the machine, not using the default operating system on the hard drive, but using the operating system on the live image. So in this case, we'll talk about all this stuff later. I'll just use a live non-persistent in this case to start up the most basic default setup. So I'm just going to press the enter key here, and I'll make another video clip to show you how to get a hold of the live image and how to use it on the machine. We'll probably demonstrate this in the class today on the 22nd. So as you can see, even though this is just a window in the host operating system, it is behaving as if it is an independent machine, and that's the beauty of using a virtual machine. And I need to carefully overlap the screens correctly so that we can show, or at least capture, most of it. There we go. And now we have started up the machine. It's a full GUI already. So we go ahead and click the username, and we log in. And I'll go through all this stuff later on when we talk about how to use the live image. Alright, so now we have a Linux desktop up and running. We can go through all of these stuff here to find out exactly what we can do with a live Linux distribution. But remember, our main objective here is to talk about how to start up a Linux box and how to shut down a Linux box. There are two ways to shut down a Linux box in this case. The first way to shut it down is to go through the GUI, go to logout, and click shutdown. But that's way too easy. We don't want to do things like that. The second way is to use a command line to do it. Okay, so now we have a command line. Now, when you're using a command line in Linux, you have to be aware of a few things, because each command line has a quote-unquote user associated with it, which basically dictates what you can and what you cannot do on the command line. So one thing we want to do is to say, who am I? Well, I am a user, a regular user, which has the name of a user, which cannot do much. In other words, if I say power off, it will say, I don't know how to do that. That command is not found. That's because when you want to power down a machine, you need to elevate your privileges to a root user, ROOT. A root user is basically the administrator of a machine, and only that user can initiate some of the more sensitive commands, and shutting down a machine is definitely one of those. So you cannot just say power off. So what we can do is to say, okay, let's change to a root user. Okay, in other words, I don't want to be a regular user anymore. I want to elevate my privileges to that of the system administrator. SU stands for super user. If you want to know how to use a particular command, you can Google that, or if you prefer, you can also use man, which stands for manual. And then you can say, okay, I want to learn how to use the command called SU, and it tells you exactly what to do, or the options to use it. But in this case, we'll just go ahead and type SU. The root user has a default password of ball in the live distribution, so you just type ball here, root ball. And now you can see that the prompt has changed. In other words, it is no longer saying user at Debian, it's now saying root at Debian. And if you type who am I, it will confirm that we are now the root user. That's good, because now we can actually go ahead and shut down the machine. Now before you shut down a machine, you have to make sure that no data is going to be lost, and no one's going to complain when you shut it down. Well, in this case, it's not a big deal, because it is a desktop machine, we are not doing anything, and nobody else is in the system. Okay, now how do I know that nobody else is in the system? I can use the command who, which tells me that only the user is logged into the system, so nobody else is using this system, because it's a desktop computer, it's not a server. Now, in the case of a server, you have to be more careful, because if other people is using the machine to do some useful stuff, and you power down the machine, you can potentially cause those people to lose some data. The file system will still be in a consistent state, and everything will still be okay, but it is still possible for some programs to lose data. Now, here's the really useful command, which is called power off. Power off is a command that is only available to the root user, and that's why when we try that as a regular user, it says command not found. But when you are the super user, or the administrator, or the root user, you can actually type this command. Now, it is important to remember, when you do this on the command line, it is not forgiving. In other words, it does not prompt you and say, are you sure you want to power off? Are you sure that nobody else is using this system? Are you sure that you want to close all these applications that has not saved the last version of a document? It's not going to ask any question. It would just go ahead and shut down the machine. So let me just illustrate it here. Press the enter key, and you can see that the GUI is gone, and we are dropping back to the text interface, and it displays a whole bunch of message, and at the very end it shows please remove the disk, close the tray if any, and press the enter key to continue. And that's because we are using a live distribution. If you are using a non-live distribution, the operating system is actually installed on the hard drive. It would just simply shut down the machine, and that will be the end of it. When I press the enter key, it will actually shut down the virtual machine as well, just like that. And now the virtual machine is gone. We are completely back to the browser. So that pretty much concludes our first video clip. We have just covered most of the topics here, and I will make another video clip to show you how to use the live distribution of Linux. And in the class, I will also do a demonstration in the class, just so that you can see visually how to do it, and I'll give you a chance to do that in the class as well. So I hope you find this useful. There will be more coming later.